Okay. Okay. Good afternoon. Today's topic is Geographic Information System Concepts and Analysis. So, Geographic Information System, we also call it GIS. So now it is popularly known as GIS technology, but it is very useful for many regions in the sense that if you want to collect the data related to the earth or its features, then you can collect in the form of the different formats, or you can analyze in the computer systems, and finally you can generate some useful information which can be further used for many applications or even in the decision makings. Okay, so in GIS basically we have data inputs, because if you want to create some database known as the GIS database, so for that we need some raw data. Using that raw data we can generate some GIS products. So data input is required, and then this we can convert, or we can put into the computer system and we can manage it, and whatever the input data is managed or manipulated in the computer system, then it is basically stored in the form of the database, and that database you can manage or edit or manipulate anytime, and so that is basically called the database management. And once the database is there, then you can perform n number of queries related to the data which is there in the computer system, and you can perform certain analysis in order to generate some useful information from the data available within the computer systems. And after analysis you can display the data, or you can generate the different types of the outputs for many applications. Okay, so GIS have the different functional modules. So these four are basically called the functional modules of the GIS. And in nutshell, GIS is a computer based system which requires the hardware, software, and the people as well as the data input for the database management and the generation. Now GIS is also works as a toolbox, and or we can say GIS is a tool for solving different types of the problems related to the geography and the other data sets. So you can say that based on the toolbox, you can say this is a set of the tools, because different types of the tools are there. One tool can be used for one purpose or more than one purpose, but in GIS there is a collection of, or the set of the tools basically arranged or stored in the form of the softwares. Okay, so now this is also called a system, and particularly known as the information system, and which is used for the data capturing and the storing the data, and then retrieving some useful information, analyzing certain data sets, and then displaying, which are especially reference to the earth. Because the name here is the geographic, it means whatever the data is there, that is geographically referenced, means whatever the data is there, that is related to the some part of the earth, means spatial information or positional information is also linked with the data set, and that data set you can handle in the computer systems. Okay, so both the type of the data, for example you have the attribute data of the any type of the feature, as well as the spatial data of that feature. So both the data, spatial as well as the non-spatial information, non-spatial data sets, you can analyze into the GIS systems. Then characteristics of the geographic data, as I already mentioned, there may be spatial data as well as the non-spatial data. So spatial data is nothing but the maps which you have already seen. So these types of the maps are basically called the spatial data, and the attribute data is basically the data about this spatial data, and that attribute data is basically stored in the form of the tables. So that sometimes also called the tabular data or attribute data, or the non-spatial data, because the location of the data set is not mentioned in the attribute tables. That's why it is also called the non-spatial data. So you can classify the data as a spatial and the non-spatial, or non-spatial data you can say the attribute data or the tabular data sets. Okay. So spatial data is basically represents the physical or actual size of the features on the earth surface, and what is the shape of different types of the features. And this spatial data can further divide into two categories. One is called the vector data, another one is called the raster data. So vector data means this data, the map of India or the Uttarakhand or the Dehradun, this is basically called the vector data or vector spatial data, because this data is represented in the form of the polygons. Each state is basically representing one polygon. So this polygon is basically a part of the vector data set. Similarly, other type of the geometries are also there with the vector data sets, like the point data set and the line data set. Here it is the polygon data set. So we can say in vector data sets, all types of the features on the ground we can represent in the form of the point or line or the polygon. So point means if you want to mention different types of the ATM locations or different types of the location of the poles, electric poles or other poles. So point types of the features you can digitize or you can mention or you can store into the computer system in the form of the points. Okay, and some linear features are also there on the earth surface, like the rivers, canals, railway lines, roads, etc. So those you can represent in the form of the line features. Okay, so line features are also in the form of the spatial data. Similarly, other areas, you can say the particular space is there or coverage is there for a particular area, then you can represent in the form of the polygons. Okay, so for example, the states or the district boundaries or the wards or any types of the fields you can represent in the form of the polygons. So point, line, polygons you can be assigned to the linear or point and the polygon features on the earth surface, but all these are basically the spatial data sets. And on the other side, the raster data set is also there. So in raster data set, all the area over the earth surface is basically covered in the form of the grids, or you can say in the form of the pixels, or you can say in the form of the rows and columns, or that is just like a matrix. So that is also a form of the spatial data set, but non-spatial data set is only stored in the tables, and this non-spatial data is basically linked with the spatial data. For example, the one row is there, so one row is corresponding to one polygon, and since one row is occupied by many columns, so each column is representing one type of the attribute of that particular polygon. Okay, so that attribute, for example, this FID 0 means that is representing one polygon here, and then shape is polygon, then ID is 42, then area is this much, population is this much, population 1, then ward name is this one, population 2, density, etc. So different types of the information related to polygon 1 you can mention here. So you can say one polygon can have n number of the attributes. So those attributes you can put in the tables, or you can store the different types of the information in different columns, and this is basically called the non-spatial data set. Now more than that, we can also relate the data set with the spatially referenced or geographically referenced data set, so that you can have this particular features belongs to which area or where on the earth surface. So that spatially reference facility is there in the GIS systems, and the attributes you can assign, and attributes basically tells what is there and what is that particular polygon or what that particular line or the point features. Okay, and then spatial relationships you can assign how the population is related with the density, or population is related to the ward number, etc. So spatial relationship you can is linked with the attribute and the spatial data sets. And then temporal components you can also assign or linked in the computer systems. Then coming to the components of GIS, because as I already mentioned, in computer system, if you want to generate the GIS data products, then four things are required. One, first of all, you need the computer system, it means hardware is required. Then in order to process or store the data sets, you need the software. So software is also a component of the GIS, hardware is also a component of GIS. And once you have both the things, then you need to have some raw data sets for generating the products. So the data is also a part of the GIS, and above all, you basically process the data set, you will give some instructions to the computer system. So you are also a part of the GIS system. Okay, so these four things you can consider as a component of the GIS, like the hardware, software, data and people are the components of the GIS systems. And the sources of data, there are n number of sources. You can collect the raw data or raw material or raw GIS data from n number of the sources. There are different websites from where you can download the data set, or you have certain instruments with you, you can collect the data from the fields, that is also the source of the input data set. Or you have some certain hard copy maps or historical hard copies are there with you, then you can scan it and you can use as a input data of the GIS system. Or you have certain remote sensing products, satellite products are also the raw product for the GIS systems. Or you have the GPS data sets or total station data set or automatic weather stations. So whatever the instrumentations are there, whatever the satellite data sets or historical data sets are there, which basically you are going to use for generating the GIS products, it means all these are called the raw data or the sources of the input data sets for the GIS products. Now coming to the spatial data models, few things I have already mentioned. The spatial data you can represent in the two forms, or you can say in the form of the two models. So one is called the raster, another one is called the vector. So here you can see this is the real world scenario, or you can say imagine this is the surface of the earth where different types of the features are there. For example, the barren land is there, forest patches are there, water bodies are there, roads are there. So these different types of the features are there on the earth surface. So these things you can represent in the computer system in the form of the vector data or the raster data. In the form of the vector data, you need to digitize all these features in the form of the point, line and polygon. You can see here the bigger areas you can represent in the form of the polygons. This is also in the form of the polygons, and the linear features you can represent in the form of the lines. Okay, and if dots are there or some specific information is there at a particular location, that you can digitize in the form of the point features. So the real world scenario you can represent in the computer systems in the form of the vector data using the point, line and polygon geometries. Similarly, if you want to represent the same data in the raster form, it means the whole area you can divide into rows and columns, and each pixel or basically the intersection of the row and column is representing the corresponding area on the earth surface. So depending upon the characteristics of these features, or suppose whatever the way you are storing the information in these pixels. So for example, in the satellite data set, the reflectances or the reflectance is stored in the corresponding pixels. So the reflectance is having its own intensity. So based on the intensity, the different colors may be occupied in different pixels. So based on the different colors combinations, you can identify which types of the feature is there on the earth surface. For example, here this blue one, it means the low reflectance will be there, and for this types of the concrete, the maximum reflectance will come. So you can say the another color can be filled over here. So this way you can represent the whole real world scenario in the form of the raster images also. So these types of the structures belongs to the satellite data, because satellite data is a raster data, and this is basically combination of the rows and columns, or mathematically you can say this is just like a matrix, rows and columns, but rows and columns are very large in numbers. So these are the two models basically. If you want to represent the real world scenario, you can represent either in the form of the vector data set or in the form of the raster data set. Okay, so more specifically you can see here, this is the vector representation. For example, this area is there and this is x y z axis. So if any type of the linear feature is there on the earth surface, so you can digitize the linear feature by a line, or the polygon, this shaded portion is there on the earth surface, so you can digitize a polygon around that shaded area, or if you have any specific things at a particular location, that you can digitize in the form of the points. So you can say this is the real world scenario, and that can be converted in the form of the point, line and polygon, and all these point and line and polygon are basically geo-referenced, means they have the locational information with them also. So locational information or positional information is there with these types of the geometries, and associated attribute information you can fill in the form of the tables. So for example, if you want to give the name of each type of the features, names you can find out, mention here, another attribute over here, another attribute here. So that way you can increase the size of this tabular data also. Similarly, the real world scenario is there, so you can generate a raster data also in the form of the line and rows and columns, and each pixels can be filled according to the features on the earth surface. So these are the two models, raster model and the vector model for the GIS systems. So these are very easy things. Now this is another important slide, which is basically related to the data preparation. Suppose somebody is interested in the preparation of the GIS data sets. So what are the different steps? Means first of all what we do, and then second what we should do, and then next, then next and next, and finally what we can generate. Okay. So step by step description is there in this slide, and more than that, at each and every step basically we make certain mistakes, and those mistakes are basically reduces the quality of the final product. So here the heading is the data set preparation or GIS data set preparation and the sources of errors. So sources of errors are everywhere, means whatever the step is there, means here these are the steps. The first step is this, then second, third, fourth, fifth and so on. So at each and every step we make the errors. Because of those errors, the quality of the product will reduce drastically. Okay. So our effort is at each and every step we should be careful, and we should minimize the sources of errors at each step. If we cannot remove the errors 100%, but we can minimize the errors. So the first step is the conceptualization, conceptual models. Means suppose you want to handle the agricultural problem, so you want to generate a GIS database for the agriculture domain. Okay. So first of all basically you need to conceptualize a perfect model for agriculture. These types of the information is required for many regions. So first of all basically you will conceptualize, you means some decision makers or some head of the institution or organizations, they basically conceptualize the model, and then next step is the data collection, means the job will be done by some other person, and this conceptualization of the model is done by the some other person, or you can say the decision makers. So at the time of the conceptualization of the model, people, though they are the higher officials, but they are also having their own limitations, and because of those limitations they are also making certain mistakes, and those mistakes are basically reflecting in the form of the errors in the GIS system. So those mistakes may be because those limitations may belongs to the decision makers or the model makers or the real world models also, because whatever the agriculture field you are choosing, so there may be different types of the characteristics over that particular field. So because of the real world scenario, certain limitations or certain errors can be introduced at the time of the conceptualization of the model, and this planning or conceptualization of the model can also be affected because of many things, or because of the people involved in this, and those people have certain limitation due to their experience and their level of education and their culture and the beliefs, values and personalities. So these are, you can see, these are some social terms, but these terms also affects the conceptualization of the model. Or you can say if the conceptualization of the model is not perfect, it means some error is there, that error will go to the next step, or you can say that this step cannot be done perfectly if the conceptualization model is not perfect. So you can say because of certain things the conceptualization of the model is not perfect, though this is the first step. Okay. So because of certain mistakes, some error is there at this particular level, which is first level. So that error will go to the next step. Okay, and the next step is the data collection, and data collection is done by some other persons, or you can say GIS expert or GIS workers, etc. So GIS collection or data collection you can do from the many sources, and those sources are divided into two categories. One is called the primary sources, another one is called the secondary sources. So primary sources means if data is raw data. For example, techniques of the geodesy, you are collecting the data, that is called the primary source of data. Photogrammetry techniques you are applying, or remote sensing data, or the surveying data, means directly if you are collecting from the field. So, or you can say this is the immediate data. So that is called the primary source of data. And if you are collecting the data from the secondary sources, like existing topo maps are there, or coverage maps are there, or hard copy maps are there, or some topo sheets are there, it means those topo sheets or hard copy maps you are using into the computer system, it means these hard copy maps are already prepared by somebody else. So so now you are using it, it means this is the secondary source, not the primary source. So either you are collecting the data from the primary source or the secondary source, and that data is also not perfect, or because that data is also having their own limitations, either in terms of the resolution or the technique applied. So because of these limitations, you are also introducing certain errors at the time of the data collection. Okay. So the some error is there at this particular level, and some error is coming from the previous step. So now here you cannot say ki both the errors will be balanced, but the errors never subtracts from one to another one, but they are basically either multiplied or the adding up. Okay. So at this particular level the error is basically increasing, and that error you can further classify into different ways, because the data collection may be not perfect because of any mistakes of the surveyor or the person who is involving in the data collection, or he is taking the wrong inputs, or wrong input data set he is taking, or he is doing faulty surveys. So because of certain these reasons, certain errors are basically introduced at this particular level also. And those errors or uncertainties you can classify like the spatial or the positional errors, and then time means temporal errors, theme means thematic errors or the attribute errors, and further you can classify like the systematic errors, human errors, random errors, and then there are different types of the errors like mean error, absolute error, root mean square errors. These are different positive error, negative errors. So but here basically this is the major classification, means the error may be with respect to position or time or attribute, and system is involved, so systematic error may be there, human error because people are involved in the data collection, so maybe the mistakes of the human, some error is introduced, or because of the randomness of the processes some error is introduced at this particular level. So now you can realize what are the different ways by which we can introduce certain errors at this level also. Okay. Now once this is done, then you can go to the next level, that is called the data storage and the inputting. Basically this work you are doing into the computer system. So whatever the raw data you have collected, you have to directly store into the computer system, and then you can input or modify that data set. So first thing is you are since you are collecting the data from different sources, so those data sets may be in different formats. So you want to open all the data set at a single platform, so that time you need to convert all different formats into a single formats. So when you are converting, it means format conversion errors are also there. Then you are basically georeferencing the input data set, so georeferencing errors are also there. Digitizing, and the digitization is also not perfect, so that is some errors is there. Then poor definitions, that is basically called the vagueness, or disagreement on the definitions, that is also called the ambiguities. So because of certain things some error is also basically introduced at this particular level, and error is here, error is here, error is also here. It means all of them are basically moving towards the next step. So that movement of the errors from the initial stage to the higher stage is called the error propagation. So the next step is the data manipulation, analysis and the processing. So at this particular time level, basically we are using different types of the tools, so GIS tools, to analyze this stored data or the inputted data. So the tools are basically made by using different mathematical formulae, or you can equate the tools as a formula. So each and every formula is not perfect, because if you are using, let us say if you want to calculate the area of a circle, so area of a circle formula is area equal to pi r square. So this formula is not perfect, means if you want to calculate the area of a circle and you are taking multiple observations over the radius, and then you are calculating this one using this formula, then you take another observation and calculate it. So the results are not same. My point here is you are taking the different observations over the radius, so there may be different approaches of calculating the area, though the formula is same. Formula is area equal to pi r square, but since you are taking observation over the radius, so there may be one approach like you are taking the mean of the radius and then you are calculating the area of the circle, or another approach may be like you are calculating the area for each radius means each observation of radius, and then taking mean of all the areas, okay, for each observations. So if you are comparing the mean of areas and the area calculated by taking mean of radius, so both the result will not be same. So that time you can realize this formula, though it is so you are using the same formula, but approaches are different and you are getting the different answers. Similarly, this formula is also not perfect. If you have the knowledge about the numerical analysis, very famous branch of mathematics, then you can see that each and every function is basically not a single function. This is basically the addition or summation of infinite terms. You can remind like the Taylor series. So each function can be expanded with respect to any location, and infinite terms are there. But here area equal to pi r square, this is only the first term, means you are ignoring the higher terms. Due to ignorance of the higher terms also, some error is introduced at this particular level, because you are using the tool and tool is based on some function. So basically my point here is all the models or the functions or the tools are not correct, and because of incorrect tools certain errors are introduced at this particular level, that is called the data manipulation, analysis or processing stage. So error is also here, then you are finally generating the products and displaying the data products. So at the time of data display, just this is basically called the mapping or maps, you are generating the maps. So at the time of the mapping, if a scale problem is there, units are problem, symbols are also another problem or representations, because each type of the feature have their own identity or standard symbols. If you are not using those or you are not following the standard units or scales, then the output or final map is basically will not reflect the correct meanings. So because of these things, only the symbols or mismatching of the symbols or the scales, you are basically introducing certain errors at this level also. Okay, so you should be very careful at each and every stage how to minimize errors at that particular stage. And finally you are selling that data product, and that is called the data usage, or you can say the final users are using this data products. And if final users are also not well qualified, or you can say the final the users are not aware about your products, so if they are not aware about it, it means that is also a kind of error. And if they are not aware about the data set, then they will misinterpret the data set. It means that is also the reason of the errors. And if they are not able to misinterpret the data set, it means they will draw the wrong conclusions. So that is also, from the starting to the end, everywhere problems are there. So problems means basically in the form of the errors. But these are the stages for the data preparation. But at each level, there are sources of errors. This is another slide, or you can say this is the summary of all these stages. For example, sources of errors may be at the stage of data collection and the compilation, data processing and data usage. Then form of errors may be primary data or secondary data, then maybe a positional error or attribute error, logical consistency, completeness. These are another terms which are used. Logical consistency means if you are using the different models, so they are basically compatible with each other or not, or you can say this is the fidelity of relationship between different types of the inputs used in a particular model or the function. Completeness means sometimes the data is over complete, sometimes it is under complete. So the completeness is also one type of the error, because over complete is also a kind of error, and under complete is of course is a type of the error. And finally you are resulting into the final products or final errors are there. Yeah, that is already mentioned. Each error is moving from the initial stage to the higher stages, that is called the error propagation. Now this is a typical slide. For example, you are ready to generate the GIS data sets of your field or your domain, whatever the domain is there. So first of all, you need the raw data. So raw data may be in the form of the satellite, or you are basically purchasing the satellite data. If satellite data is you are purchasing, it means that is already georeference data. Since the satellite data is a type of the raster data, so you can have the directly raster data set. Or you have the topo sheet. This is another way of having the raw data. If you have the topo sheets or hard copy maps are there with you, then first of all you have to scan them and then georeference them into the computer system, and those georeferencing can be done using the GCPs, or you can use a Google map or the Bhuvan portals. Okay, and this georeferencing you can do any GIS software like the ArcGIS or QGIS. If you are doing in QGIS, then Google map you can directly access, and that Google map can be used for georeferencing, and the GCPs can be collected directly from the Google map in QGIS software. So my point here is, either you have the satellite data, that means you have the georeference data set. If you don't have the georeference data set, or input data is in the form of the topo sheet or hard copy map, first of all scan them and then georeference them, and thus you will have the georeference data set, that is also in the form of the raster data set, because topo sheet is a continuous or hard copy map is a continuous map, and once you are scanning it, it means that is another raster. Okay, so this way you will have the georeference data which is there in the form of the raster. Or another way may be like, suppose you are the engineer, then you are using the AutoCAD softwares, and AutoCAD softwares you are basically having the DWG formats files, different files are there, or you are the engineer, civil engineer, so different buildings, corridors, or the city structures you are generating. So all the files are there, those are called basically AutoCAD files, and the format of those files is generally DWG. So those files you have, then first of all you have to convert the DWG format into DXF format. So conversion in DXF format you can do. Once you have converted into DXF format, then DXF format you can convert into shape file. Okay, so conversion in shape file. Once it is in shape file, or shape file is basically vector data. Okay, and once you are having the vector data, then you can georeference it after a fine transformation and putting the GCPs etc. And this vector set data set you can georeference, then finally you will have the georeference data, and that will be in the vector form. Okay, so this vector form you can directly use into the computer system, and this raster data you cannot directly use into the computer system, but this data you can use for generating another vector data set, or you can say this data set can be used as a background layer, and over that background layer you can generate the vector data set. Okay, so now you can see here, this is the database, database creation in another step, and in database basically three types of the geometries you will have, like the buildings, parking panels, these are the polygon features, or you can say polygon geometries, and these are the roads, water pipelines, electrical cables etc. These are the line features, and poles, trees, water tanks, fire hydrant points, inspection chambers etc. These are the point features. So basically you have created the different layers with these names, with the different geometries into the database, GIS database. Then what you will do is, whatever the vector georeference vector layers you have, those vector layers you can directly import into the database. And another way, and since you have, if suppose all the vector layers you don't have, only few vector layers you have, those you can directly import here, but other layers you don't have, so those layers you can create using this raster data set. So what you will do is, the georeferenced raster data is there, then you can edit it, editing, digitization, attribute filling you can do, or you can say this you can use as a background layer, and you can open these layers, and these layers you can digitize over the raster layer. It means these layers will basically have the data. Once you are digitizing it, it means the entry of the data is basically started. So using this one, you can enter the data into different layers. So by this way you can have a complete database. Okay, so this is another basically slide which gives some instructions. If you have different types of the input data sets, so how to generate a GIS database. Then once it is ready, or you can say each and every layer, in GIS we call it the layer, so each and every layer is having the data set. So that data set, basically each and every layer is having data, it means the database is ready. Once it is ready, then you can perform certain types of the queries or analysis, or you can generate certain maps, or you can update anytime, means whatever the data set you have generated. Now if you want to update it, you can update anytime. So these are the functions available with the GIS systems. Now this is another important term, that is called the data quality. That is very important thing and very useful thing, because quality is useful everywhere. Whenever we purchase the products, so we basically talking about the quality, means what is the quality of that particular product. Whether we want to purchase the tables or chairs or cloths or the TV or computer, whatever we want to purchase, first of all we are basically trying to understand or trying to judge the quality of that product. Similarly, in this GIS product, quality term is also associated, but only difference is, if you want to purchase, let us say, table, then table quality you can judge in terms of many parameters, and above all your experiences matters basically, means by seeing the table, or you can touch the table and you can have certain feelings about the quality of that particular table. But you have the data set, GIS data set, so you cannot touch the data set, so you don't have the feeling whether the GIS data is good or bad, or you can say quality is good or bad. Okay, so touching or physical contact is not possible with GIS data, but other products have the physical contact, so that you can also having certain feelings about the quality of the products. So quality, you can say certain useful things, or you can say some sense of excellence of that particular product is called the quality. So as per the ISO standard 2002, the definition of the quality is mentioned in this way: the totality of the characteristics of a product that bear on its ability to satisfy stated and implied needs of the users, basically. Okay, so if basically a product is satisfying you perfectly, it means the quality is good. If it is not satisfying you means it is not serving your purpose, or it is not completely serving your applications. Okay, so that way you can judge the quality of this product. So as you already aware, in the data preparation there are two people are involved. One is called the data producer, another one is called the data user. So as a data producer, you need to take care of these points, and as a data user you need to take care of these points. For example, you are producing the data set, then you have to check with the specification for the data set. Means before generating the data set, you first of all look into the specifications of the data set, and once it is prepared, then you have to again check, does the data set meet the specifications or not. Once it is done, then you have to check the quality is reported or not. And more than that, you can see the quality is not judging in terms of a single parameters, multiple parameters are required. So those parameters are different for different types of the products. So for the GIS data products, those parameters are also different. Okay, we will see those parameters, or you can say the elements of the quality. So I think in next slide we will discuss those things. So as a data user, you are purchasing the data set from some agency directly, and then directly you are using. So at a data user, you need to understand these things, 3 points. One is the data of sufficient quality for your application or not. Means before purchasing you basically judge my application is this one and I want the data for this purpose. So whether this data set will satisfy all the needs of my application or not. So first of all you need to check this one, and then able to interpret the producer's quality report, because once the producer is producing the GIS data product, he is also supplying some quality report. So you need to understand the quality report also, so that you can have a certain ideas the spatial resolution of this data set is this one, and this agency have prepared this data set, and this satellite data was used for the preparation of this data products. So such kind of the information is there with the metadata or the quality report. And more than that, you should be aware about the constraints awareness. Constraint means some restrictions. Restrictions may be with respect to the finance or maybe with respect to the accessibility of the data set. Basically that is legal or illegal. So constraint means what is the cost of that product. Means for your application that much cost is feasible or not. Or you can say if your application is very simple and there are number of products available, and so you can compare which data set is low cost and which data set is satisfying you perfectly. So in that way you can judge the financial constraints as well as the legal constraints. For example, sometimes the data sets are not accessible everywhere. For example, some data sets are prepared for the military purpose, some data sets are used prepared for the civilian purposes. Okay, so you cannot purchase the defense data sets because those you cannot access. So that is also a kind of the restriction or the constraints. So as a user you should be aware about the financial as well as the legal constraints. Another this chart basically showing the concepts of the quality, especially internal and the external quality. So this shows basically this is the real world scenario on the earth surface, and you are the producer, then you are basically generating certain specifications, and based on those specifications you are converting this real world scenario into the computer system in the form of the GIS data set. Okay, and then your data set is there in the computer system and reality is there on the earth surface. Then you can directly compare your data set with the ground reality. So your data set is not perfectly matching with the ground reality. It means certain deviations are there, and those deviations basically reducing the quality of your product. If your product is 100% matching with the ground reality, it means the quality is very good. Since it is not perfectly matching because nothing is ideal, so some deviation is there. So because of that certain deviations or you can say the quality is reduced, or you can say certain errors are introduced in your data set. So whatever the deviations are there, so that is a measure of the quality. Or you can say if n number of producers are producing the products or GIS product of the same area, so the deviation for different products will be different. It means you can compare the internal qualities of the one product, another product and another product. Okay, so that way you can say this product is having the good internal quality as compared to the others. But here you can see internal quality is only and only one, because you are directly comparing your data product with the ground reality. So this is called the internal quality. Once data set is produced, then you are selling it. So n number of users are basically purchasing it. So and they have the different agenda or different applications, and let us say user number 1 is 100% satisfied with your product, then that fellow will say the quality of this product is very good or excellent. And let us say user number 2 is not 100% satisfied, or let us say his satisfaction level is 70%. It means he will say the quality is not very good. Okay, and if let us say another user is not satisfied with your product, it means he will say the quality of your product is bad. It means the product is same, but different users are mentioning the quality of the same product differently. So this type of the quality term is called the external quality. Okay, but nowadays the quality of the spatial data or GIS data product is very big issue because of the many reasons, whether it is availability of the huge satellite data, or because of the availability of the high performance computers or GIS systems, or maybe because of the internet, because different agencies are there worldwide and they are producing the GIS data set, and they are sharing on the internet. So users are very careful and they are comparing one data with another data. So if you have made any mistake as a producer, it means your data set will not be purchased by anybody. It means if you are not serious, nobody is serious about you. So that way the quality is very big issue. But major things are uh, because huge availability of the data set, internet, or the GIS technology. Earlier days people were preparing only the hard copy maps, and those were limited and those were not shareable on the internet. So that time the quality was not very big issue, but nowadays it is very big issue. Nobody will accept if you have made any mistake. Now we will start around the GIS database. So database is nothing but you can say structural format into the computer system. So where we can store the GIS data set. Okay. So this is the example. For example, you have the books and then you have the cabinets. So first of all you can search the cabinet and then you can search where is my book and where is this book and on which page this is there. So this catalog you can prepare. So this catalog type of the things you can prepare into the computer system regarding the GIS data sets. Okay. So you can compare the GIS database just like this scenario, just like a library where you are first of all you are going and then you are searching the catalog, then you are going in that particular rack and then searching the book and then serial number of the book, etc. So all such type of the things you can do into the computer system, especially for the GIS database preparation. Then what is DBMS? DBMS means database management system. This is also a computer based system where you can perform or store or construct or manipulate the database. So the database, basically whatever we were discussing, that was the database management system only. That is a kind of the software which is there in the computers, or you can say GIS database. Now basic database concept is this is also very basic requirements. For example, you want to handle certain students in the classroom, and at the university level or college level you have the database of the students. They are having basically their roll numbers, classes, their ages, and different types of the status, whether they have paid the fee or not. So all such information you are basically putting into the registers. Okay. So all these informations you can put into the database directly. So few things you can put into the tables, and tables are also having the records and the fields. Record is just like a row which I have already shown in the attribute table. So one row is called record, or you can say one row is corresponding to one student. So in that one row different columns are there. So in different columns you can mention what is the age of this student, in which class he is, or what is his roll number, and in which section he is, like that every record you can mention, and that is called, one row is called the record, and each column is called the field. So single item, or you can say in one field one information you can store, like this one. Suppose this is the table and the name. So this is the column, this is another column, another column, another column. So one column is one field, another column is another field, like that, and these are the records. One row means one record. Name is Smith, like user link is this one, phone number is this one, college number is this one, class is this one, like that. So this types of the field generally we are putting into the registers, but now you can directly put into the computer systems. Now typical functions of the database management system, like the controlling the redundancy, because if you are using the hard copy registers, it means if multiple records are there in the register, you cannot control them, or you cannot catch them directly. Either you have the mental intelligence, that way you can find out this student is having the double records on this page or this page. But if these types of the things are there, you can directly catch into the computer system. So you can say you can control the redundancy into the database, and restricting the unauthorized access, because in computer system you are putting certain authorization, or you are basically giving some username, password, etc. So that way you can restrict, and providing the multi-user interfaces and representing the complex relationship. For example, you can put the certain queries, and then based on those queries you can sort out, means suppose 100 students are there or 1000 students are there, you can perform certain queries and you can screen them, sort out them, shortlist, select and wait list it, like that. That way then things you can do. And the enforcing the integrity constants, you can also mention here. Providing the backups and recovery, means data sets you can put or you can take a long term backup rather than putting the multiple registers here. Then advantages of the databases are like data independence, efficient data access, data integrity and security, data administration, concurrent access, crash recovery, reduced application development time. So all these are the advantages of the database. Now coming to the geospatial data analysis, we will spend 5 to 10 minutes over this. So now till now we have understand GIS is having either vector data or the raster data, and then database management system is there, and spatial as well as the non-spatial information is there, which we can analyze further. So how we can analyze those things we have to see. Now questions a GIS can answer, like the location, where is, what is the, at what place, and condition you can apply, means these types of the questions may be there in your mind. So all types of the answers can be answered by the GIS system. For example, you want to analyze the pattern of a particular things, like the what spatial pattern exists over this particular data set, that you can analyze in the computer system. Modeling you can do, and then like the why we want to do, answer the geographic questions, like where is the nearest school to my home, means this is the spatial context, means this is the query with respect to the spatial distance. Then the make informed decisions, if you want to take certain decisions or you want to take any actions or changes. So these are the things by which we want to apply the GIS, and all such types of the question can be answered with the GIS systems. And the methods are like the simple queries or spatial queries. Single layer operations can be performed. Multi-layer operation, single layer means only one GIS layer is there, you can perform the queries over the single layer, or multiple layers are there, you can perform the questions, or you can say you have the queries which requires multiple layers. So multiple or your question, your query can be solved using multiple layers also. Then surface analysis, like what is the water flow, in which direction water accumulation or flow accumulation, like that. So surface analysis can be done. Network analysis, like what is the shortest path, what is the closest facilities around this particular facility, or what is the vehicle routing problems, postman problems. Those things you can analyze very easily in the computer systems. Then point pattern analysis, like the if you want to perform certain interpolations, those you can perform into the computer systems. Spatial modeling you can do if you want to identify a location or suitable location for the construction of a particular school or your building or any warehouse kind of things. So the site suitability analysis you can do into the computer system, especially in the GIS system. Then what role does GIS play in a spatial analysis? So this is already explained. So you can say you can handle the geographically referenced data set. Spatial attribute data entry and update capabilities are there with the computer in GIS system. Data conversion functions are there. Storage and organization of a variety of spatial and attribute data. Manipulation of the spatial and attribute data. And then presentation of display capabilities are there with GIS systems, and spatial data tools are there. Those tools you can see now. Yeah, you can remember or you can point out in GIS system, especially for the spatial data set, there are different tools for the vector data as well as the raster data. Means the same tool cannot work over the both the data sets, like the raster or the vector. So for the vector data set, if you want to overlay the maps, then these tools are there, like union, intersect, point in polygon, line in polygon, polygon on polygon. So these are the overlay functions over the vector data set. Similarly, the map manipulation, Dissolve, clip, append, eliminate, update, erase, split tools are there for data manipulation. Proximity analysis like buffering, multiple ring buffer, point distance. Pattern analysis tools are there like the spatial autocorrelation, nearest neighbor analysis. Network analysis like shortest path or shortest route, and then closest facility, service area analysis. TSP means traveling salesman problem, BRP vehicle routing problem, CPP Chinese postman problem, MST minimum spanning tree problem, SDP supply demand problem. So these are related to the travel as well as the transportation problems, you can say. Based on the raster data, you can see the functions are local, focal, zonal, global functions are available in GIS system. Map algebras are there like operations, Boolean algebra, relational, arithmetic. Functional may be there, mathematical, logarithmic, arithmetic, trigonometric, power, terrain analysis, derivatives, contours, slope, aspects, hill set, view set, hydrology analysis, flow directions, etc. So here you can see the logical, arithmetic and relational operations like A and B. Suppose two layers are there and you are performing the AND operation, then you will get this types of the output. Means one layer is there, another layer is there, and both the layer are having certain common portion with them. It means, and then if you are performing the AND operation, so whatever the common portion is there, that will be highlighted. Similarly, if two layers are there and you are performing the OR operation, so the entire area will be. So this is the simplest. These are the based on the set theory. So all these operations are available with the GIS system. Similarly, arithmetic operators you can apply, plus, minus, multiplication, division. Relational operators you can perform, and then trigonometric operators you can also perform. Means you have certain GIS layers and you can perform the trigonometric operations. Suppose in one column, few values are there. Now you can create another field using the sign of that previous field. So these trigonometric operators can be applied. Similarly, some spatial relationships also are there. If two layers are there, if you want to judge whether they are disjoint or not, so disjoint is can be identified. Similarly, whether they are meeting or not, or whether they are equal or not, or inside or outside, covered, contains, covers, overlap. So this situation you can easily identify. And these are also like union, clip, dissolve. These are self-explanatory. You can see. I will share this PPT. And the buffering, multiple ring buffers are also there. Around the line features you can create the rings, or you can highlight a particular space within a fixed distance, and you can create a multiple rings based on the some range of distance, let us say from 0 to 50, 50 to 100, 100 to 150, like that. So those are called the multiple ring buffers. Overlay operations you can perform. For example, different layers are there, then all the layers, this is the point layer, this line layer, polygon layer, another polygon layer. So all of them you can dissolve or overlay. So all the layers you can visualize in a single layer and you can see the map like this. Overlay operations, vector layers. So for example, one layer is this, another layer is this. If you are overlaying both of them, then final output will be like this, and the attribute information will also be changed. Okay. So now overlay operations, the intersect means this layer is there, this layer is there, and you are performing the intersect operator. So this type of the output you will get. Attribute information will also be changed. And these are the operation over the raster image, and the raster is just like a matrix. So whatever the operations you can apply over the matrix, the same operations are applicable over the raster images. So for example, the output image means output image of the raster image you want to create, then you have to raster calculation expression. It means you have to write an expression based on the input rasters, whatever the number of inputs are there. For example, here one raster is there, map A, map B, and now another map you can create like map C. So map C equal to map A plus 10. So it means using map A you are creating map C just by adding 10 in each and every pixel. So the another map is generated. Similarly, map C1 equal to map A plus map B. So this type of the you can generate map C2 like map A minus map B upon map A plus map B into 100. So this type of the product. So this is basically the operations. These are the mathematical operations which you can apply over the raster images. Similarly, this is another for classification. This is another classification. Okay, the spatial selection queries, you can perform these queries over the raster data sets. Like this is the non-spatial information, this is the spatial information. Now if you want to select a particular polygon, then the corresponding record in the attribute table will also be highlighted, or you are highlighting this particular row in the attribute table, the corresponding polygon will be highlighted in the database. Okay. Similarly, if you want to highlight multiple polygons in the database, so corresponding polygons or records in the attribute table will be highlighted. So this is basically a two-way communication. If you are selecting one, another one is automatically selected. So special selection by attribute conditions. For example, here if you are performing certain queries based on the attribute data, because area is less than 4 lakh, it means area is less than 4 lakh means this information is there in the attribute table, it means this is called the attribute query. If you are performing this, so whatever the areas are less than this value will be highlighted, you can check here, and corresponding polygons are also highlighted. Similarly, some logical operators you can apply, like area is less than this, then area is less than this, and land use is equal to 80. So for example, area is less than this, and means this is a combination of the attribute queries. So one question is based on the area, another one is based on the land use category, and both of them you are adding with the AND operators. So if both the conditions are satisfied, then output is correct, otherwise no. So you can say if area is less than this, if you see this particular record, so the area is less than 4 lakh and the land use is 80, so the land use is also 80. So both are correct, that's why this record is highlighted. For this record, this is 30, it means land use is not 80, that's why it is not selected. This is 70, it is not selected. So whether both the conditions are satisfied, corresponding element records are highlighted and corresponding polygons are also highlighted. So this way you can perform different types of the queries in the GIS databases. So this is also one type of the example. Classification can be done. Now this is related to the transportation analysis, that is called the GIS analysis. This is self-explanatory, few points I have mentioned, and different types of the applications are there, like the shortage problem, supply demand, this I already mentioned, Chinese postman, maximum flow problems. And yeah, so this is from my side. Now if you have any query, you can mail me, or you can paste here. Thank you very much.